Hello, good day viewers. Welcome back once again. Today we're going to solve this Olympiad mathematics problem. We're given the following quadratic equation: a to the power of 4 plus a squared minus 1 equals 0. And here we're going to evaluate a to the power of 12. Now let's get started. From the given equation a to the power of 4, we can actually write it as a to the power of 2, then squared. Then we have plus a squared minus 1, this is equal to 0. Now from here, let us make the following substitution. We're going to let a to the power of 2 equals m. And from here, we're going to derive the following equation in terms of m. So we have m squared plus m minus 1, this will be equal to 0. So from here, we're going to solve for the value of m, and we're going to make use of the general quadratic formula, right? So we have here m is equal to negative b will be negative 1 plus or minus square root of b squared minus 4ac is square root of 5 here, then divided by 2. Okay, now from here, let us recall back that a squared equals m. So here we have a to the power of 2 is equal to negative 1 plus root of 5 divided by 2, and also a to the power of 2 is equal to negative 1 minus root of 5, then divided by 2. From the given equation, we have a to the power of 4 plus a squared minus 1, this is equal to 0. Now let's move these two terms to the right, and they're going to have opposite signs, right? So we have a to the power of 4 is equal to negative a squared plus 1. Now let's go ahead and multiply both sides by a to the power of 2. So we have a squared multiplied by a to the power of 4. This will be equal to a squared multiplied by negative a squared plus 1. So from here, we have a to the power of 6. This is equal to this times this will be negative a to the power of 4, then plus a squared. And from here, we have minus into bracket, then the value for a to the power of 4 here, negative a squared plus 1. So we're going to substitute. So we get negative a squared plus 1. Then don't forget plus a squared. So we get a to the power of 6 is equal to here, negative times negative a squared is positive a squared. And don't forget we're adding another a squared, so that will be 2a squared. And here minus times plus 1 will give us minus 1. Now here we're going to evaluate a to the power of 6, right? So we have here a to the power of 6 is equal to 2 into bracket a squared. Remember, we have negative 1 plus root of 5 divided by 2, then we have minus 1. And from this side, we have a to the power of 6. This is equal to 2 into bracket minus 1 minus root of 5, then divided by 2, and we're subtracting 1. From here, this 2 we cancel this 2, this 2 we cancel this 2. So we get a to the power of 6 is equal to, here we have negative 1 minus 1 is negative 2, and we have plus root of 5. And I'm very sure the other one should be the conjugate, right? So that would be negative 1 minus 1 is negative 2, I mean. So, and here we have minus root of 5. Okay, now from here, before we proceed, let us take note of the following. When we have a plus b to the power of 2, this is equal to a squared plus b squared plus 2 times a times b. And when we have a minus b squared, this will be equal to a squared plus b squared minus 2 times a times b. You know why? We're going to square both sides of this equation, and something similar to this will come up, right? So here we have a to the power of 6 squared. This will be equal to negative 2 plus root of 5 squared. And from the other side, a to the power of 6 squared. Then this will be equal to, let's factor out the negative sign. So we're going to have minus 1 into bracket 2 plus root of 5, right? Then the whole of this squared. Okay, from here, 6 times 2 is 12. So we get a to the power of 12. This will be equal to the first term squared. Make use of this binomial expansion. So we have negative 2 squared plus root of 5 squared, then plus 2 times the first term, negative 2 times the second one here, root of 5, right? And from here, a to the power of 12. Then negative 1 squared is 1, right? So we're left with 2 plus root 5 squared. We have the first term there, 2 squared plus root of 5 squared, then plus 2 times root of 5. Okay, so from here we get a to the power of 12 is equal to, here this is 4 plus here that will be 5 because square cancels root sign, right? And here 2 times negative 2 times root of 5 will give us negative 4 root of 5. And from this side here we have a to the power of 12. This is equal to 4 plus 5. Then plus 4 root of 5. Simplifying, we get a to the power of 12 from here. This is equal to 9 minus 4 root 5. And from here, we get a to the power of 12 is equal to 9 plus 4 root of 5. So we can see that this is the conjugate of this. So here we come up with a solution to the Olympiad mathematics problem that a to the power of 12 is equal to 9 plus or minus 4 root 5. And this is the solution. Thank you for watching. Please kindly subscribe to my channel. Also like, comment, and share. Bye-bye.